hopefully, it'll start going a little faster going through these examples. I'm now referring to, again, the same document that I have been, if you've been following the YouTube clips in order, this document is called ztableexamples.pdf, and I'm now referring to example number 3, which gets a little bit more complicated, but really not so much. Here's the deal. Again, we have what I refer to at the top of the page, generic test scores. I'm asking you to assume a mean of 7 and a standard deviation of 3. And the question is a little bit more complicated. What portion of the population scores between 12 and 9? Or I could have just as easily said 9 and 12, it doesn't matter. What portion of the population scores between 12 and 9? Well, look what I did. I drew the normal probability distribution, the normal curve. I drew my two abscissa lines. I cut it in half. I put a z of 0, a mean of 7 there. And then, what else do I know from the question? What portion of the population scores between 12 and 9? Well, if this is 7, where does 9 have to be? 9 has to be above 7. 7, 9. Where does 12 have to be? 12. Right there. 7, 9, 12. Doesn't have to be proportionate. This is just about solving the problem. So the next step, as you could probably guess, is I need to convert those raw scores to their corresponding z-scores, and that's what I did right here. A raw score of 9 converts to a z-score of 0.67, and a raw score of 12 converts to a z-score of 1.67. So then I place those appropriate z-scores there. Z of 0.67 corresponds with a raw score of 9, and a z of 1.67 corresponds with a raw score of 12. Now that I have z-scores, I can then turn to the normal probability distribution in order to solve this problem, but it's a little bit trickier because look at the question. What's the question? The question is what portion of the population scores between 9 and 12? So what portion answers that question? Right here, this one right here. This is the area between 9 and 12, right there. Well, how do we isolate that area? How do we figure out how big that area is? Pretty easy, actually. All you got to do is find the bigger portion and then subtract the smaller portion from it. So for the bigger portion is going to be the portion between mean and a z of 1.67. And I'm drawing right now. I realize I'm not making a mark or much of a mark, if anything, but I'm drawing around the larger portion, right? The larger portion. And then I need to find out how big that larger portion is, and then find out how big the smaller portion is. This is the smaller portion, the portion between z and a z of, between the mean and a z of 0.67, and then subtract this portion from the larger portion, and that's exactly what I did here. The area between the mean and a z of 1.67 is 0.4525. The area between the mean and a z of 0.67 is 0.2486. All I got to do is take 0.4525 minus 0.2486, and I get a value of a proportion of 0.2039. That's how large this portion is. That answers that question. What is the question? The question is, what portion of the population scores between 12 and 9 or 9 and 12? And the answer is 0.2039. And we figured that out by discovering, first of all, the z-scores that correspond with those two raw scores, and then isolating the portion that answers the question. Isolating the portion that answers the question, the portion between 9, a raw score of 9 or a z-score of 0.67, and a raw score of 12 or a z-score of 1.67. Example 4 is exactly the same thing, but on the negative side. So go through that nice and slowly and see how that goes. Example 5 ups the ante a little bit, so I'm going to break this off and then start another portion.